Hello guys, how are you? Welcome back. Yano re level force resolution, right? So we are going to resolve forces. So rari, two forces can be added together to find a resultant, right? Yano, a single force can be resolved again to break it down into two components. Forces at right angles, rather two components A, so again x and y components. So harana le a vector. I'm gonna resolving forces, but it has to be vectors because as you force here, remember level displacement there, velocity, right? So this is what we have. So rather harnally a vector, it's finally a vector, right? You can 10 meters per second, give velocity 10 meters per second, 10 meters per second, give velocity, guys. Rather, we can break it down into two components, x and y. Okay, rather give v, moena v y, moena v x. Moke the vertical component of this velocity, moke the horizontal component of this velocity. So let me use a straight line, right? Yes, supposing it is like this. We are dead shock as one 1000 newtons force this time around. So we can break this force down into its y and x component. So this is in happy calling hana since we're in line with this one again. Yes, yes. V ma v f y. Then we're gonna let that on the horizontal. Yes, it's on f ma f x. Rather at right angles. What do we mean? We mean to say between these components y and x has sensor 90. I get sensor 90. Men happy or heinz and we can write this method. I get or in this case we can write f f ma. This is in the vertical, therefore it's f y. Then we rewrite join this force even f ma f x. And remember here again get 90 degrees. So this is how we resolve forces. But can I talk another video 1000 10 I 10 to help us with trigonometry a given angle. Guys. I get yes. So trigonometry. Let's go to the next slide. Trigonometry triangle. Okay, let's jump right there. Well guys, trigonometry and scale drawing. So For the first part, there is a trigonometry. Okay. Let's consider the use of SOHCAHTOA to determine the components of force. Okay. Yes. SOHCAHTOA is used to find the missing sides or angles of a right triangle. Right triangle. It can be useful in real-world applications. Yes. In real-life situations. Sine of theta equals opposite over hypotenuse. What do you mean by that? So sine theta is equal to opposite over hypotenuse. I get opposite opposite side to the angle. Maybe I should go ahead and label the angles here. Ke change gore se ka nna ka re angle ya rona e nna e le gogolo 1 ke be kae makebe. Yes. So harnal angle ye high ke sine of this angle is equal to opposite over hypotenuse. Hypotenuse ke engana ke the longest side in. I get ke yone long gore ke yone the longest side. Tsena tse pedi tse ba le mo ga gore gape they are at what right angles tse pedi. Okay. So the long side are denoted H for hypotenuse. Then we have opposite. Opposite what? Opposite what? It's very important. Okay. Opposite the angle given. Angle key. Angle is swaragane le side haya swaragane le gore opposite. Okay. So this is opposite. Berenale adjacent side. I get adjacent ke the side e lore tshwaragane le angle means hypotenuse for a A. I get ke yo A ke mo kwadile. So go ra gone gore sine of theta equals opposite over hypotenuse. Sine of theta, sine of this is equal to opposite over hypotenuse. Right? Then yone itsamaya yare cosine of theta equals adjacent over hypotenuse. Cos theta is equal to adjacent over hypotenuse. Adjacent over hypotenuse. So cos of this angle or what cos here this angle. Cos is equal to cos theta is equal to adjacent over hypotenuse. Right? Tangent of theta equals opposite over adjacent. So tangent of theta is equal to opposite over adjacent. Opposite over adjacent. Opposite over adjacent. Ke gone be re nna le SOHCAHTOA. Okay? Hard thing so hard level this is the long side. I get on a hypotenuse. Hypotenuse H. This is the angle theta. Go tla tswa mo go ena gore nako e is a sine kana cos kana tan. I get me go dependa gape le mo gore what do you have. Do you have the opposite and hypotenuse? Then you can go and use this one. You have adjacent and hypotenuse, you can determine this. Do you have this and this? You can determine this. And also if you have the angle and the opposite side, you can find the adjacent. If you have the hypotenuse and the angle, you can find adjacent side. I get it. So here hypotenuse, then this angle is opposite this one. So what are again opposite side? This angle is adjacent. Adjacent to adjacent. Then we are angle. So to determine what opposite again, adjacent again, you need to have an angle. You need to have an angle because adjacent to the angle, opposite to that particular angle that has been given. Hypotenuse if you're not going to se na angle ka re o lemoga gore ha re ka change ra tsisa nenyane angle ya go ra adjusting the opposite ya change. In this case ye ke here ke opposite ye tshwaragane le angle ke adjacent okay mme a re ka ntsha nenyane ye ha be re itsenya go ra re tshwaraganeng le angle ya nnae ye go ra re ya change ye nna opposite ya nnae e be nna opposite yana ke sone se sengwe se se botlhokwa se e leng gore tshwanetse re se itse tshwanetse re se itse guys. Okay guys, go ra gore a re heleng gone in the next lesson ra go apply this yana ra go lebelela dipotso be re kgona go solve a few questions re dirisa SOHCAHTOA okay yeah remember re resolve di vector. Thank you, let's meet on the next lesson.